So let's work with the third problem of the homework. We got four pegs of the same diameter, A, B, C, and D, and they are attached to a board shown. Two strings pass around the pegs and pull with the forces indicated in here. So we got two forces of 60 pounds and two forces of 40 pounds. The 60-pound forces are horizontal and the 40-pound forces are vertical. Determine the diameter of the pegs, knowing that the resultant couple applied on the board it's going to be 1132.5 pounds inches. That means we will have a total moment couple equal to 1132.5 pounds inches. We know that the couple will come from these two couples moments together. That means we'll have one moment couple 1, moment couple 2, moment couple 1. Let's work with the 60 pounds forces. It's going to be distance y times the force of 60 pounds. The moment couple 2 is going to be distance x times the force of 40 pounds. Now, we already know what's going to be the total couple. Positive, it tells me it's counterclockwise. That means we go like that. And we can see that it actually is correct. Look at the forces. We got two forces vertical, and the one on the left is going down, and the one on the right is going up. That means it will kind of make a motion like this. Then we got the horizontal ones, that the one on the upper side is going to the left, the one on the lower side is going to the right. So we will have a motion like it. Both are going to be positive. So we will have positive moments for both calculations. Now, how do we set what's going to be the diameter? Well, I know that the distance 12 inches is from center to center, as we can see in the drawings, and the 9 inches is center to center. However, the real distance between this action line and this action line right here, which is the x, already includes the radius of the pegs. So the distance x can be actually written as the 12 inches plus one radius from here, one radius from here, 2 times radius. The same for the distance y. The distance y is the distance between these two action lines. Distance y. And that distance y will include the 9 inches that we got from here and one radius from here and one radius from here. That will deliver 2 times radius. Since we know all the radius are the same, and we know the addition of these two moments delivered one total moment, we can get to this equation. Moment C equals to moment 1C plus, C1 plus moment C2. That means moment C equals to distance y times 60 pounds. However, distance y is going to be 9 inches times 2 times the radius times 60. So we will just submit the units. We know it's going to end up being newtons, pounds, inches, and pounds. So 9 plus 2 times the radius times 60 plus distance x times 40 pounds. And the distance x is going to be given by 12 inches plus 2 times the radius. All that times 40. From here, since we know radius of the pegs are equal, we can just start solving. Moment C equals to 9 times 60. That 9 times 60 is going to deliver 540 plus 2 times 60, 120 radius, plus 12 times 40. That 12 times 40 is going to be 480, and 2r times 40 plus 80 radius. So we solved for r. Solving for r will give me that r equals to mc minus 120 over 20. Oh, sorry, 200. Since we know what's the value for the MC, that's going to be 1132.5 minus 1020 over 200. We can get that the radius is going to be equal to 0.5625 inches, like that.